Okay, hi everyone. What we're doing right now is we are learning how to do special factors. All right, here we go. So we have special types of factors. We've been working on trinomials so far, but we have a special type of factor today called a difference of two squares. A difference of two squares. Sounds like a tale of two cities to me. A difference of two squares is when I'm having a number that's a perfect square, means a number times itself. So our example here is going to be our easy x squared minus 4. X squared minus 4. Now whenever you see something squared minus something squared, okay, it has to be a minus sign. Pluses don't work, and I'll show you guys why pluses don't work right now. But minus signs are between the two squares. We could automatically say this. This is factorable because what times what is x squared? X times x is x squared. And what times what is 4? 2 times 2. So we have the numbers that we can to populate the factor. X and x make x squared, and 2 times 2 is 4. Okay. And let me give you another one. If I say x squared minus 25, well, isn't that x times x and 5 times 5? So this is not a trinomial. But we'll see why is this still factorable. X and 5 times 5, right? 5 times 5 is 25. X times x is x squared. We're all looking good here. Let me do one more for you. 4x squared minus 9. So how do I get 4x squared? Is this a square also? That's 2x times 2x and 3 times 3. So we can write our factors 2x, 2x, and 3 and 3. Okay, hopefully you guys can all see the pattern. If I have a difference of two squares, a square in the front and a square in the back, and we're subtracting, the word difference means subtraction. We actually have almost an auto answer now. It's almost automatically going to be this. Now, I want to ask you this follow-up question. In order to get a negative 4, can these be plus plus? No, because a positive times positive is not negative. Can these be negative negative? No, because the negative times negative is still positive. So these have to be a positive and a minus. They have to share one sign each. Now, when I do this, let's go ahead and multiply 4 and see what happened to our middle term. We normally have a middle term here, x squared plus something x. And then we have our constant at the end. So there's always a something x here. With all the problems that we've done, we always had a something x. But what happened here is if let's go ahead and multiply that. X times x is x squared. X times negative 2 is negative 2x. Okay, we're done with the front. Let's go ahead and do the back. 2 times x is positive 2x. And 2 times 2 is negative 4. What happens to the middle term? They always cancel out. So one thing we want to realize about these problems is that the middle term always cancels out because we almost have identical twins here. One good, one evil. They punch each other and they knock each other out. That's why there's no middle term here. Let's see if it's the same for the next problem. X squared minus 25. To get a negative 25, we need a plus and a minus to get that negative 25. Plus and a minus. Now, if I double check this problem, x times x in the front is x squared. Back, negative 5 and positive 5 become negative 25. And the middle term would be positive 5x and negative 5x. Negative 5x and positive 5x. So what happens to a positive and negative here? They always cancel out, leaving me x squared minus 25. So our plus and minus seem to do the trick. What about this weird one over here, where I end up with a 2x in the front and a 3 in the back? Well, again, to end up with that negative 9, we can't have them both as positive positive. We can't have them both as negative negative. So we need one of each to become a negative 9. Positive 3 times a negative 3 gives us that negative 9. And when we double check, 2x times 2x in the front is 4x squared. We can do the back. 3 and negative 3 become negative 9. What happens in the middle? Well, we would end up with a negative 6x plus 6x. As you can see here, they all cancel out, leaving me just the front and the back. So when we see these difference of two square problems, we want to remember that this is factorable, and this is like super easy factorable. They're twins, but they're plus and minus. They're twins, but they're plus and minus. X squared plus x squared minus 144. Can you think of a number that multiplies to 144? That's an exact twin. 12 times 12, right? You got it. So this is x, 12, 12, and we need a plus and minus. Automatically, that's what it is. This is as much work as you need. Okay. Give me 1 second. Okay, so does this get any worse? Well, what if I say 25x squared minus 25x squared minus 4? Would you consider this a difference of two squares? A square in the front and a square in the back. A square in the front and a square in the back. Would you consider this a difference of two squares? Well, 5 times 5 and 2 times 2. Right? 5 times 5 and 2 times 2. So this is a difference of two squares. So I want you guys right now to see if you guys can break that up. Before I jump in there and give you the answer, could you break up and figure out what would the difference of two squares be? Okay, we said 5 and 5 in the front, 2 and 2 in the back, x and x, right? 5x, 5x gives me 5x squared. And if I do plus and minus, that gets rid of our middle terms. Does it get worse than this? Well, what if I write, let's do this one. 8x squared minus 18. Okay? So 8x squared minus 18. This doesn't look like a difference of two squares. And you're right, it obviously isn't when we first start, because there's no number times itself is 8, and there's no number times itself becomes 18. But as I mentioned before in class, when you factor, can you find anything in common first? If you can factor something in common first, the problem becomes super easy. Are there any numbers in 8 and 18 that we can factor out that are in common? Do they both have a 5? Do they both have an 8? Do they both have a 3? Do they both have a 2 in common? Hey, doesn't 8 and 18 both have a 2 in common? So if we factor out a 2 first, we're left with x squared, 4x squared minus 9. Now, take a look at this problem now. 4x squared minus 9, is that a difference of two squares? 4 is 2 times 2, 9 is 3 times 3. We are golden. 2 and 2, 3 and 3. We can see that is 2x, 2x, and 3 and 3. Plus and minus to get rid of that middle term. So sometimes difference of two squares aren't obvious, but if we can get rid of a common term, it becomes a lot more obvious now. So these are special factors. We have one more set of special factors that we want to make sure we know. And that's, what if we have a square of two terms? So here we go. Let me show you. If I say x plus 2 times x plus 2. X plus 3 times x plus 3. X plus 4 times x plus 4. Now sometimes you might read this as x plus 2 squared, or x plus 3 squared, or x plus 4 squared, a squaring a binomial. Now, if I multiply this out, we're going to end up with a pattern, and this pattern is kind of helpful if you want to write out all the work. But let's do it for the first one. X times x, x squared. X times 2 is 2x, okay? Not that hard. Now we multiply the 2's turn. 2 times x, hey, don't we end up with twins? And 2 times 2 is 4. We always are going to end up with twins here. Let's see if it happens in the next one. X times x is x squared. X times 3 is 3x. 3 times x, oh, since these guys were twins, we're going to repeat our term, 3x. We either get 3x in the back or 3x in the front. We always end up with twins. And 3 times 3 is 9. Okay? You guys see the twins? What do you think is going to happen to the next one? X times x is x squared. X times 4 is 4x. And we said we're always going to end up with twins. Now, here is the pattern. You square the front. If I say x plus 2 squared, you square the front and you square the back. Okay? X plus 3 squared. You square the front and you square the back. X plus 4 squared. You square the front and you square the back. 4 times 4 is 16. But what's that middle term? We were always going to double the middle. So I want you to take a look at this. If I say 2x, are you guys okay with 2 times x is 2x? Let's double it. What is double 2x? That's 4x, positive 4x here. What's double 3x? 6x. What's double 4x? 8x. And the pattern is, if you have a square of a binomial, you square the front, you square the front, you square the back, and you double the middle. Square the front, you square the back, and then we double the middle. Okay, doesn't seem too hard of an idea, right? Now, even if this was 2x plus 3, the rule still holds. We square the front. 2 times 2 is 4, x squared. 3 times 3 is 9, and we double the middle. What are we doubling? We'll just multiply 3 times 2. 3 times 2 is 6x. But we're doubling it, so that becomes a 12x. We always double that middle because the term is going to repeat twice. Now, knowing this rule, if I give you a problem that says x squared plus 6x plus 9, you're probably thinking, isn't 3 times 3 9? But is 3 plus 3 6 also? Automatically we know this is x plus 3 squared. Because 3 plus 3 is that 6. We actually double the middle, so going backwards. So these are special factorings. If you can see that this is a squared at the back and doubling for the middle, x squared plus 10x plus 25. What do you think would be our numbers to make 25? And do those numbers also make 10 in the middle? 5 and 5. Does 5 plus 5 become 10? X plus 5. X squared minus, what if I put a minus sign here? How will this change? Well, it's still 5 and 5, but what if they're both negative? Won't that give me the negative 10? We double the negative 5 to become negative 10. X minus 5 now. So knowing these special cases helps us factor a little faster. Could we have done this a classic way? Yeah, we could have. But this is just that next step to realize, hey, these are actually a square. This is actually doubling the same term. If I give you another, let's give another one. 4x squared, we'll say plus 9, and then we're going to say plus 12x. Okay? So we have 2 and 2 in the front. We have 3 and 3 in the back. And isn't 2 times 3 6? We double 6 to become 12. 6 and 6. We know this is a perfect square of 2x plus 3 squared. Okay. And that's it for our practice of factoring. So we've gone through most of our factoring when it comes to trinomials and binomials. We have one more lesson on factoring that we'll do on Tuesday next week, and then we'll prepare for the test. Okay? And that's it.